Welcome back to Business Analysis Techniques. This is your online instructor, Diana Block. And this week we're going to talk about some decision-making options and tools. And so again, I want to start off the discussion by looking at the assignment you're going to complete. And we'll talk about how some of these decision-making tools discussed in your textbook will help you to solve the problems for your assignment. So here I've got your assignment for this week. This is problem 1. And we see that they have provided us with some information. If you read the instructions up here in blue, it's basically telling you that this person is considering opening a service station, and she's trying to decide which size station she should open. Some projections have been done as to what she could make in a good, fair, or poor market based on the size of the station. And so she's unsure if the market is going to be good, fair, or poor, but she does have some information as to what that would look like as far as dollars. And so you're being asked some questions about which store she should open using different types of decision making. Now this first part asks which store should she open if she uses max and max decision. Now, if you read through chapter 3, you will find that max and max means that she's going to use the most optimistic decision. She's going to take the most optimistic view, which would mean it's going to be a good market, and you're going to go to whatever size station has the largest payout in a good market. And that's as simple as that. You'll just put in your green box, and I made notes over here for what you should look for. But in the green box, you'll put the store that she would select being the most optimistic. Then it asks on the next line, what's her max and min decisions? With the max and min decision, it's the exact opposite of optimistic. We're going to take the pessimistic view. So the pessimistic view means we're going to assume it will be a poor market. So we're going to look at the outputs that are here in the poor market. If we have a poor market, we want to maximize our returns there as well. So what number of this gives us the maximum return of these minimum numbers? So we're taking the pessimistic view. We're going to look at all the bad numbers and get the best one out of those. So then on the next part, part C, we're going to look at which store we should choose using equally likely. Now with equally likely, all we're going to do is get an average. We're going to take an average of the small market and put that response there. Average of medium, put that response there, and so on. You're going to get an average of the returns for a good, fair, or poor market for each size of station. Once you have all the averages here, you're going to choose the location size that has the highest average. And so that's what you will use for the equally likely criterion answer here. And so the final part to this problem is the criterion of realism, and you will have read about that in chapter 3. If you haven't, you will this week. So I'll just go over the formula here. With the formula, what we've done is taken a weighted average, and so we've got a formula that you're going to use to get a more realistic averaging system. And the short version of it, since you're going to read it in the textbook, for our notes here, you're going to take the maximum, which is in these cases, the good market, times 0.8 plus the minimum times 0.2, and you're going to be able to get the criteria of realism values here. So on each of these lines, you're going to take the maximum times 0.8 and the poor times 0.2 and get your criterion of realism result here. Then you'll determine which one of these we should choose based on that information. So make sure you read up on that in the textbook, because that's the only one that's a little bit different, and it uses a new formula that you'll have to make sure you have correct in order to select the right choice there. let's look at problem or question 2. And I've got notes in here too. Notice my notes. This is for us to help you. And in problem 2, you're calculating expected monetary values. And again, you will have read about this in your textbook this week. But expected monetary values allows you to determine what is the overall value of an investment considering the potential different states of results. So in this situation, again, you've got a good market that it could be, or it could be a poor market. And up in the paragraph, it tells us the chances of a good market are 70%. Chances of a poor market are 30%. So to get the expected monetary values, you're going to use the formula in their textbook, but basically the formula is, my shortened version is the probability, I'm using P for probability, the probability of a good market times the value in a good market, plus the probability of a poor market times the value of a poor market. And so that'll tell us the expected monetary value of that particular piece of equipment. And then you'll do the same formula for this row, the Euler J equipment, put that response there, and the same thing for this row. You'll take the probability of a good market value times 70%, plus the probability of a poor market times the value of a poor market. You add those two together, and then you've got the expected monetary value. So based on whichever of these is the highest, that's what piece of equipment you should select, the one that has the highest expected monetary value. Now the EVWPI, and you'll read about that in your textbook, and basically you're going to take the best payoff in the first state plus the best payoff in the second state. So that's saying you're going to take the best payoff that's in this row plus the best payoff that's in that row, and of course each one you're going to multiply times the probability of a good market times the probability of a poor market. So let me say that again. You're going to take the probability of a good market, which is 70% in this case, and multiply it times the best result in a good market. So your best choice here times 70% plus your best choice here times 70%. That is what EVWPI is. So that's the expected value if we had perfect information. So if we had perfect information, we would always have the best choice in each state of being. And so the next part, once we have the EVWPI, we're going to subtract the best expected monetary value from it, which remember the best expected monetary value we've put here. We chose it from the numbers here. And the EVWPI minus the best EMV comes out to be the most that you should pay for either piece of equipment that you end up choosing. So I know this sounds like a lot of terminology in the video, but once you read the textbook, what I'm saying will be a lot clearer, and you'll be able to just follow the steps. Let's look at this last problem in these last few minutes that we have. This is your decision tree, and this problem is really very similar to the last one. You're calculating EMVs, expected monetary values. And so the same formula that we just talked about for expected monetary value, let me go back and show you. The formulas we used for here, the probability of a good market times the good market value plus the probability of a poor market times the poor market value, EMV. That's what we calculated here. That's what you're going to calculate in this problem as well. So for example, we've got, it's asking for the expected monetary value at node 6. So what happens is if we scroll down to see what node 6 is. Node 6 is a large shop, and so we're going to determine whether it's a favorable market or unfavorable market, what the EMV is. And so remember, we've got information down here, and that tells you the values you would get from a large shop and a small or large shop if it's favorable or unfavorable. So we've got that information about large, small, and no shop for a favorable market, large, small, and no shop for an unfavorable market. We've also got probabilities over here. The probability of a favorable market, depending on if you do the survey or not, might be 50%, 90%, or 12%. And then the unfavorable is the flip side. So in each of these nodes, you'll just have to consider, first of all, whether the survey was done or is not done, or whether the survey was done. So you see these are going different directions based on market survey or no survey. Then once you get to that sub-level, we have a large shop, no shop, or a small shop. Remember, all of that information is here. And so in node 6, we've determined it's going to be a large shop, so it could be either favorable or unfavorable. And so this is the no survey, favorable or unfavorable for the large shop. So it's a lot more of it, but it's really the same information as in the last problem. So once you have read your text and went through the PowerPoint slides associated with it, then you'll come back to this video and see how I've shown you how to work these problems out. The main concepts you need for this assignment are the maximax, the maximum, the equally likely, criteria of realism, and then after that, you're going to be calculating EMVs. EMVs, expected monetary values, and expected value at perfect information. If you have any additional questions about this, give me a call if you need to. Send me an email. We can even talk about it in the discussion area if you want to talk about this more or you have questions about this. Because I know for most people, this is going to be brand new information. So yeah, we can definitely talk about it more. I look forward to hearing from you this week, and have a great week.